sorry about the wait, and I think we're back from the commercial. So, my first topic is just the discussion about the data mining project. So, if you came on the stream on Wednesday or watched the video after it was uploaded, you'll know that I've been working a little bit more on the data mining project. And since Wednesday, I've done a little bit more on it as well. But there's been some changes in my state of mind in terms of how I plan to tackle this task. Originally, I was thinking that I would need to completely just trash what I had done before, and not necessarily trash it, but just go through and rework each individual piece. And although I am still planning to do that, I am keeping a lot of the code that I was originally using for previous previous deep learning projects. So what's different is obviously there's some big changes in how the data mining project works, and one of the big ones is how the DNA files are set up. So previously, I would have a randomly created DNA file that is not necessarily completely random. It's random based off of a set of parents, and those parent files, which are considered the better of the previous generations, would provide two possible options. And so of those two possible options, one of them would be randomly chosen based off of a weighting, off of the scores of the two parents. And then there'd also be a random possibility of a random mutation. Now, this worked very easily because the entire structure of the DNA files were completely stagnant. They were always, in the case of the previous project I was working on, they were always 1,250 different numbers. And so that meant that when I went in and made a random selection for a given mutation, I could it was pretty easy because there was no changing in the size of the actual file. Now this is something that's changing because in the previous stream I said that I wanted to make the actual AI a little bit more dynamic, and the way I'm doing that is I'm giving it free rein on how big of an answer it wants to create. Now this could become problematic, but I'm planning to also add in some precautions so that it doesn't run on forever, because I think this is going to be something that can be completely run to exhaustion or to tolerance in the case of this in one day, perhaps even in a couple hours, maybe even shorter than that. I'm open to be surprised by this, but I don't think this will be the day upon day running that the ball drop or the environment project was. So I think this one will be a little bit simpler, and because of that, I'm working it into being a little bit more dynamic. And so by dynamic, I mean that the actual structures of the data themselves can be resized as the AI requires it. And so I'm going to pull up a paint screen here and just kind of explain this a little bit. So previously, I would have a file and it would just have a bunch of numbers. So you'd have like a 1, 0, 2, 164, 7, 3, 5, and this would just keep going on. And these numbers were specific to individual characteristics of an if statement. Now, if you don't know what an if statement is, I would suggest either just looking it up on the internet, or I have given a brief description of it on a previous stream. But basically what it is it's a conditional statement used in programming. So pretty much any programming language has an if statement structure because it allows for dynamic programs. So if a specific condition is seen, then the program follows a different path than if it were if the condition is not seen. And so there's some extra bits here and there about special kinds of ifs, but that's the general concept. So that was the idea that I was basing the entire program on. The AI would create if statements that would be the instruction manual, per se, for the task it's attempting to play. But this is a different task because it's not a game. This isn't something where if I just turned it on by itself, it would run even though it's not being given any instructions. So this is something where I provide the program with some data, and it provides me with an algorithm for replicating a specific variable. And so I've talked a lot about this on the big data. I've talked on big data stream. I've talked about this on previous streams about the data mining project. But what this is basically doing is, instead of creating if statements, so this is if, there's going to be individual pieces of an equation. So you'll have, let's say you had blank, or here, well, let's put some variables in here. A plus B minus C. This has three different pieces of the puzzle, and this will equal some answer Z, I don't know. So we have this piece, we have this piece, and we have this piece. Now, these pieces can be broken down into individual sub-pieces or subparts, because this A, which is a variable, may be dependent upon other variables. So let's say this A breaks down into x plus y over q, and this B could be m times n, and I don't know why that's uppercase, so n. And maybe this is just its own thing. But as you can see, each individual piece can have a different size than its next door neighbor. So this C would be pretty simple because maybe this is just one of the input variables. But this B has two variables within it, and these variables could be split up again. And A has three variables, and these variables could be split up again. So you can see what I'm saying is that the if the AI wants to create a correct representation of the variables or of the pieces of the puzzle and then put them all together, it needs to create small equations within the big equation in order to get the whole picture. And so this is why, if you actually remember the equation from the previous stream, or the equation that I've shown for the data mining project that I plan to use as a test for the data mining project once I feel it is up to the job, it actually is one huge fraction with many little pieces in here and operators in between. So this would be something like A equals Z, and this A is actually broken down into a bunch of different pieces, which are broken down into even smaller pieces. So it's very complex, and that's why I think it's a pretty good task for the AI to attempt to accomplish. Now, I do plan to try simpler equations, probably something as simple as this with no dynamic stuff going on, just to make sure that the algorithm I have written is running properly. But this is the end goal, to have this huge, very complex fraction and see if the AI can at least approximate it through many pieces or actually get down to the correct answer. So that's what's going on with the data mining project, but you will remember, if you've seen the previous stream, that I was planning to somewhat restructure how I had individual pieces that the AI could create. Now, I realized that this was somewhat redundant because when I created my deep learning algorithm, or the adjustments to the previous neural network to make it more deep learning oriented, I created I changed how the variables are handled because so what I did in the deep learning algorithm, or the deep learning changes, is I had so we had our original variables, and I've explained this a couple times, but I'll go over it again because it's pretty straightforward. So I have the original input variables. Now these input variables are trying to explain some variable, I don't know, A. And so we have X, Y, and Z, and the network, the neural network, is trying to explain A using these three inputs. Now, perhaps a random linear combination of these three inputs will completely explain A. But usually that's not the case. In life, there's a lot of dependencies, and even in the situations where there's not, we're usually making assumptions. A lot of physics-based and other things that have equations that are seemingly linear and independent with their variables, they aren't. They're usually approximations, and there's something going on behind the scenes. So what the deep learning algorithm does is it takes the input variables and it just tries out different dependencies. So what it could do is maybe it would create some variable that's 3x plus z, and it would actually no, that's not a good idea. Let's say it's 3x y divided by z. And so this in itself is an equation, but then this specific equation could be added into this linear combination with the input variables to create the answer A. So this is what deep learning does. It creates new variables that are complex, and it creates new levels. So this would be a second level, whereas these are on the first level. And perhaps once the deep learning algorithm keeps going, it could take this variable and throw it, let's call this one Q, and it could throw this in with the previous input variable. So maybe xq over zy is a tier 3 variable. And so you get the idea. It constantly creates new levels of variables, and so that's why it has this deep aspect. But what the benefit of this is that it can actually create very complex equations simply by creating new variables that are combinations of the equation of the previous variables that it has to work with. And so I was saying in the previous stream that the Lagrange interpolator could be pretty easily created through the deep learning algorithm, because it's just like x minus some constant over some constant minus some other constant. And actually that doesn't make sense. It's this way. But you get what I'm saying. So this is not too complex of an idea. These are all just numbers, and then this is one variable. And so what this does is it actually can be a switch, so it will turn on when the value is this, but it will turn off when the value is this. And so I've explained this whole idea in a previous stream. But what I was saying is that I was thinking of using this as an asset for the AI, but I thought that it was actually pretty easy for the AI to create on its own. And because there were similar things that weren't necessarily Lagrange interpolators, because they were like x minus y over x plus y, this has the same basic concept, and the deep learning algorithm can create this on its own. So what I plan to do now is to actually incorporate more operators into the deep learning mutations. So what I have included is so what we had previously was plus, minus, multiply, and divide. And so, I'll make that a little bit more divide-y because it kind of looks like a slash mark. Okay, so these were what we were working with before, and the AI could create combinations of variables using these. Now, what happened a lot of the time was it would create variables that would then have zeros on the denominator, and they would not work out. What I did was I just simply I said that if a error occurs because it is trying to divide by 0, then just throw that variable out. So what happened was the fitness score was completely dropped, and the variable was of no use because for what I was working with, there was no reason to divide by to even like get close to dividing by 0. There was no reason to approach that limit. So so this is what we were working with before. What I've added in is the power function, and this is a function that's listed in Python, but what it is it's just x to the y. So what I did was I said it can take what has been previously created, and it can put another variable as the power of that variable, and then that's now what we're working with. And then I also added in cosine. Now, I am still tossing cosine around in my head because this is not necessarily an operator between variables. This would be a mutation of a variable that is already existing. But that doesn't necessarily mean it's not important, because cosine is something that shows up a lot. Also, I'm planning to add in the constants pi and e, because pi and e also tend to show up a lot, and if there's something that needs to be explained by e to the x, then it will be able to create that by first including e and then using the power function. Sorry about that. So with these extra additions, I think that the AI, through deep learning, will simply be able to achieve the equation that we are hoping, or any equation, because that's the idea. This is supposed to be a general algorithm. So that's the idea of what's going on with the data mining project. I have made a little bit more progress on it, but I did have one instance where where my IDLE crashed and I had to redo what I was working on. It was more of organizational stuff, so I was kind of scanning through my previously written code and deciding what needs to be changed for the new project. It was most of the functions and most of what's going on in the code, but the idea is the general structure is already there, so I think I should use it. So that is my whole discussion for the data mining project. If there's any questions about that, you can post those in the chat. I'll try to answer them. If not now, I'll answer them at the end of the stream. But for now, I am going to play a quick ad, and we'll move into my random drawing section, which I've done for the entirety of this show. So you have that to look forward to, but I will be right back.